Hey, we're live. Good to see you again, guys. Hey, we're live. How's everyone doing today? All right, give me a second just to get things ready out here. As you can see, I'm not sitting at my desk as I normally am. I'm out in the shed today. So give me just a second to get things up and running. It's a bit of an experiment today. We'll have to see how everything's working. Oh, I think we're going to play chat box roulette again to see if it's working. That's all right. How is everyone? Can you hear me okay? Is it coming through clearly enough? Cool. All right. I think we're actually up and running. So, welcome to my shed. I'm not going to be doing any coding today, nothing like that. Instead, I'm going to be assembling one of the new Dropbear boards. This was something that I had planned for the weekend, so I thought, why not see if there's any interest out there to do a stream of it. And there seem to be a few people interested at least, so here we are. What I'm going to be working through, it's a little bit of a long process, so this is probably going to be a couple of hours at least, this stream, because this does take a little while to get working. What you can see in front of you is a Dropbear board all laid down, using my somewhat ghetto process for hand assembling surface mount boards. I'm using a new fancy document camera thingy, which seems to be working okay, but I'm having some driver issues, so that the frame rate's a little iffy. So excuse that, but we'll forge on nonetheless. So what's the plan? This is the board that I'm going to be working on. It's the Alpha 4 for Dropbear. It has a few feature additions from Alpha 3. It also has a few things that have been fixed up or generally improved or just finalized. So it's going to be a very similar process to what I did with assembling the Alpha 3, and I did a video a few weeks back around sort of DIY assembly of surface mount work. It's going to be following very much the same process. I'm going to work through all of the surface mount components first, then do a few of the through-hole bits, and we'll take it from there, and fingers crossed we'll have a board up and running at the end of the day. So I'm just going to sort of talk my way through things. Matt, can I respond to your message on Slack? Yeah, I'll have a look. So the first thing I'm going to be doing, as you can see, I've sort of laid the board out in my ghetto way of holding it here, which is basically taped in between a bunch of other boards. Let's hope this camera can figure out what to do here. It is a bit blown out. There we go, that looks a bit better. It's just taped in between a bunch of other old boards. I was sort of wondering which boards I'd set up. These are some old plug and play boards here, but I'm getting a stack about that thick, I reckon, of Dropbear test boards and things like that. Cool. Hey, great to see people from the US. Where's everyone from, by the way? Just drop your location in, because I'll be really interested to see. What I'm going to be doing, or what I'm going to be using today, is one of these stainless steel stencils, which I'll lay over the top like this and cause havoc with the camera, no doubt. Let's see if we can. Give me a second. I might just turn off the overhead light while I'm using the stencil, because its reflection's pretty bright. Give me a second here. Oh, that's not terrific either, is it? Wow, maybe it was better with the light on. All right, let me try with the light on again. All right, so we do only need the stencil for the first part, so let's plow through and hope that it's fairly quick with this. All right, so basically what we do is we take our stencil, we line it up with the board underneath. Um, I tape it down and lay out some solder. So let's get to doing that. This is not the most precise process in the world, but it works well enough. It tends to over deposit solder just a little bit, um, but that's all right. It's something we can fix up by hand afterwards. All right. Just catching up with chat here. Do I code for a living or just a hobby? Basically just a hobby. Um, I've said a few times that I'm slowly but surely working towards hopefully making Speeduino my full-time gig. But at this point, we're a little way off that. All right, that's lined up pretty well. I'm just going to lay out some tape to hold that down. Now, this is a really massive stencil. Normally, the stencils that you get are much closer to the actual size of the board than this. So this one's going to be a little bit tricky to work with in that regard. But that's all right. We'll puzzle our way through it. And again, apologies for the terrible camera vision at the moment. It's just from when all the stencil's down. I think it's being so reflective, it is mightily confusing the camera here. Let's just move it a bit. Making a hash of this, aren't I? Alright, that's not bad. Okay. One of the trickiest bits can be holding this sort of flat while you do it, because it's easier for it to lift up, which will get your gaps between your stencil and your board, which just means you get a little bit of solder under running. It's not the end of the world, but it will mean that you might need to do a little bit of cleanup work, particularly on your fine pitch chips. Things like your resistors and everything will be okay, but some of the really small chips here might need a bit of cleanup work. So all I'm doing is running through and laying some tape down around the edges of that stencil right now. The actual laying of the solder paste here only takes, I don't know, 10 or 15 minutes at the start, maybe not even that. And then we can actually get on to the bulk of the work, which is going to be placing components. Let me just grab my solder paste here. Any plans for data logging, SD data logging on the AT megaboards? That's a really good question. The SD logging isn't written yet. I have only done the very basic rudimentary bits of it. That said, I do plan on using the standard Arduino library for SD, so there's no reason it shouldn't work. But that said, I haven't tested it and don't really know at this point whether it'll work on the on the old Megas or not. All right, this is when I discover I'm out of solder paste. Or... All right, so here we go. Just that really is terrible, that light, isn't it? A tube of solder paste here, which I'm just going to lay out in a few areas of the board. I'll start up here. You don't need that much solder paste, believe it or not. It's very easy to lay down too much, which just ends up with a bit of a mess. Oh, and I forgot to take this out of the fridge last night, which means that I've got really cold solder paste, which means it's really tricky to get flowing.
Any ideas?
I know that camera really is awful, isn't it? Maybe that helps a little bit. Hopefully you can at least see what I'm doing here. We might start with that amount, and we will need a little bit more, but we'll flow these bits in, or push these bits in, I should say, and see how we're looking. All right, let's start with that. Right, I'm going to use my trusty old Kid Shrek card here. I don't even know where I got this, but I've used this for just about all my solder work, and it seems to work really well. It's just got the right flexibility to it. Okay, so all I'm going to do is use this to smear the solder paste across the board and working into the stencil. Being a little bit more sparing on the solder paste this time than I usually am, simply because I find that I tend to over solder paste things, and I end up with blobs that need to be reworked later. So I'm trying this with a little bit less solder paste, just to see if that makes an improvement. Put out some more solder paste here. Sorry, I'm just not watching chat for just a second at the moment. I'll come back in a tick just while I get this done. Where have I missed here? match up a little bit more. Now, like I've said, this is not the most professional method for doing this, but it's not bad for a home DIY job. You wouldn't want to assemble tons of boards this way, but for one-off and test boards, it seems to work fine. Again, apologies, I know the camera is doing some crazy things here. That the stainless steel stencil really confuses it, but give me a second and I'll be done here. Just a touch more. Okay, I think we're getting pretty close here. Just have a final look. I reckon that's pretty good. All right, let's get rid of this horrible stencil and we'll see how we look. Vibrations on a board, that's a really good question. There's nothing on the board that should be too bad. Depending on which, if you're doing a hand assembled V0.4, they have a number of fairly tall chips on them. Oh, I've just moved that board, which is not ideal. All right. They have a number of tall chips on them for the MOSFETs for the injector drivers, as well as the power regulator. Those you might want to secure down, Ty. But other than that, everything should be okay. If you're using one of the pre-assembled V0.4 boards, then you're probably good to go. One thing I do have to show off, by the way, is I got a bunch of new boards arrived just during the week, all testing boards. And I'll show a picture of these later. But this is a plug-in board for the V0.4 line, which basically plugs on top of it and simply has a nice connector over here, a nice waterproof connector, and otherwise just takes care of everything else. It's got the VR conditioner built on. It allows the plug through of the DRV stepper driver and gives you a nice lockable waterproof connector. So that was just a test board, and I'll show one of those assembled fairly soon. And I realised I was an idiot and just put it over the top of that other board, which is a bit dumb. But anyway, I think we're all right. Okay, so now we start the really fun job Let's see if I can fix this lighting a little bit. Of basically putting down all the components. Yeah, there's a little bit too much solder in a few spots there, but that's all right. All right, that looks a bit better, doesn't it? All right, this is a pretty long and pretty tedious process. Basically, we run through and lay down all of the surface mount components first, typically starting with all the small resistors and diodes and things. That is a pretty long job. It can be good fun to do in the sense that it lets you get a good understanding for where everything's laid out on the board and everything like that. But it is just a long process, and I'm just pulling out all my big stack of resistors here to start working through. Where are we? And then we can start laying them all out. Oh, I did have this box all sorted. All right, here's a stack of resistors. So resistors and capacitors. I've got another machine just off to the side that I'm going to use for just searching in KiCad where the parts are, because it makes it a little bit faster. And let's lay into it, I guess. There's no easy way to do it. What solder mixture am I using? It's a, what do we go? 6337 mixture, this one. Now I've also got a bomb listing here that I'm going to be using. Wow, you really can't see on that camera. It's very overblown, isn't it? Let me just try that light again. All right, I think that might work a little bit better. All right. The really fun thing with these, or sorry, not the fun thing, the worst part, in my opinion, of actually laying these out is getting these things out of their tiny, crappy little packets that they come in, and not sending half of the tiny little resistors halfway across the room. All right, let's make a start here. R50 over here. So any questions about the whole process of doing these by hand or anything like that? I wish there was a nice fun way to say, let's just let's do this quickly and get out of the way, and we can go through a nice montage. But unfortunately, this part of the whole process is pretty long, laying out all this. In fact, I might just skip ahead. I might, for those who are interested, I might lay out some of the more interesting bits of the board first, actually. And I know it's a little bit silly to say interesting bits on a board like this, but there are some chips that are a little bit more interesting than others. We'll start with these. So these are the we're just going to lay out the two op-amp chips, which are used as part of the analog circuits. Smallest part I've got on this one is it's mostly 0805 in terms of the passives. I do have, I think that one I just laid was slightly smaller. What was that one? Yeah, that was an 0603 on that one. But most of them are 0805. Some of the pitches on some of these chips are much, much smaller than 0805 though. The ICs, just, that's how they come. They're pretty small, pretty fine pitch on a lot of these. I think the worst is, I think the worst might be the VR conditioner on this. Although the system controller chip is pretty tiny as well. Now, one of the fun things can always be figuring out which way your chips go around, what their orientation is. I've actually got one of the older boards just to use as a reference, which makes things a little bit easier in that regard. So which way do these go? That way. Now these don't have to be absolutely perfect because they will get pulled into place a little bit, but we get them as close as we can. Oh, you could hardly see that one, could you? So I was just placing this chip up here, and I'm going to do the one beside it just over here next. So why do we need these? Given that most of the sensor inputs that we're using are 5 volt, and this is a 3.3 volt ARM-based board, we need to convert those signals down from 5 volt to 3.3 volt. To do that, we use just a basic voltage divider circuit, but the downside of the voltage divider is that it saps the current from the sensors. Pardon me. And that means that it's slow, or it can slow the analog reads down. So we use these op amps instead, in addition to that voltage divider, in order to make sure that we've got plenty of current to feed the ADC circuit. Where do we go next? I'll leave that guy for a bit because he's tiny. Yeah, okay, we'll leave this one out. So I'm going to lay this one in here next. This is part of the input protection circuit. It's a clamp that is on all of the inputs to the board, and essentially watches for anything that's going over voltage, and will clamp it down to the required level. It will mean the signal will go to garbage for anything that's analog, but it will at least mean that the board won't be damaged. You can do this with a series of diodes or something like that, but this is just a nice little multi-channel TVS in one simple package. Which way does this go? Is the right way around? Yep. I don't have the steadiest hands in the world, so I need to take a couple of goes at these sometimes. That's not bad. Yep. Oh, where did the stencil come from? Yeah, really good question. The stencils you can get pretty much from any PCB manufacturer these days. They usually just have a when you upload your PCB design, they quite often just have a little tick box that says stencil or another little area where you can select stencil for it. They're generally only maybe $15 along with the board. They do, they do quite often add quite a bit to the postage because they come in this big packet, depending on the size of the stencil. But yeah, that they just come from the same manufacturers who make the PCBs. What else have we got that's a little bit interesting? Might lay these guys next. These are three of the general output controllers. So these control things like the idle. Look at him. Now I've switched the chip between the Alpha 3 and Alpha 4 boards to use one that's slightly better suited to a 3.3 volt system. The last one I was using had a gate threshold that was, I think it was from, what was it, 2.7 volt up to a maximum potential of 4 volt, which meant that it wasn't necessarily guaranteed to turn on at 3.3 volt drive. And I did some testing with it, and whilst it did switch on, it wasn't in its fully open state or fully on state, which meant that you couldn't drive full current out of it. It was really close, it was really borderline, but in the end I elected to swap the chip on it because it was not quite good enough. So I switched over to a chip that is lower total current, but does have that 3.3 volt drive capability. And it is still plenty of current out of these. I think they are 3 amps per channel, 3.5 amps per channel, I think. Now, because they're a new chip, I'll just need to confirm which way around they go. Give me a second, I'll check on this one. Yeah, okay. So, chips like this, instead of having like a dot or anything on the chip themselves, have a groove that runs down the side of the chip, which can be a little hard to see sometimes, but lets you identify which is pin 1 on them. So it should mean, because they're very, very similar to the chips that we used on the last one, just a different model in the same family, they should be the same in terms of lineup, and they are by the looks. Yep. So that makes things a little bit easier. Bear with me while I just get these all in a line, facing the right way. All look lined up to me. Okay. Not sure how well I can zoom in there. Let's have a try. This is not meant to be a microscope camera. I might try hooking that one up a little bit later when we get to looking at the soldered board and seeing how close it is. But it gives a pretty good close up. I don't know if you can see. Yeah, you can see the writing on those. So yeah, that helps also in telling which way. Looking at the board sideways there. Also does help indicate which way around the chip should go. Okay, easy done. Just shut this far up. All right, not bad. Geez, I think I can see it clearer looking at the screen there than I can looking at it on the bench. All right, what else have we got? Which ones are these? All right, so I'm going to have to, here's a chip I'm going to have to look up because it's a new addition on this board, but it's an interesting little one. Let me just grab it out. It's something I've just added onto this board for testing. It may or may not make the final board, this one. We'll have to see. But it is a little accelerometer. So I'm putting it on just to have a bit of a play with and see if it works. But the idea being that if it does work and it reads well enough and it doesn't interrupt anything else, then it'll be a really nice one to have for onboard measuring of G in 3 axes. If I can get it open. Okay. But it wasn't on the other board, so I'm just going to have to look up what orientation it goes in. It's a very, very fine pitch chip, this one. Bear with me just a minute. I'll look up the markings over here. So it's going to be, just while that's loading, this chip over here, U9 it's listed as. So a very, very tiny little chip, or quite tiny little chip anyway. Like I said, no certainty that this will stay on, but it would be a nice little thing to add. And I had a bunch of free IO, so I thought, why not? Okay, let's have a look. Markings. I've just got the data sheet open on my other machine here. Okay, so it should be a circle marking, is there? There is. Yep. Okay. So you should be able to see how much more zoom have we got here. You can see there's a little circle marking in the top left here, indicating pin 1. So that's how we know which way around this chip goes. Cool. All right, so that's him done. Yes, we have. All the way down. Actually, there's another very, very, very tiny little chip next. And it's a tiny little MOSFET that's used as part of the new crank and cam input that allows us to have ground switching input and 12 volt input on the same line without having to swap jumpers or anything. It uses this tiny, tiny little MOSFET, which I'm going to have to try and figure out which way around it goes. So we're going to be looking at Q2 here, which it's kind of hard to tell, but it is really tiny, this one. Bear with me a second, guys. I might just... Actually, I'll lay this first, and then I'll have a play. It's really tricky to see which way around this goes. That way, okay. Just check I've got that the right way. Yes, it looks the right way. Pretty good if I'm looking at that right. What I might just try, guys, is, and I only thought of this while I was going to sleep last night, but I think if it's going to work, it might work better than what we've got. I might just try switching over and seeing if I can get my microscope working here, because that would be quite a bit easier to work with. Let me just check if it's going to work. Like I said, this is a slightly less organised stream than my usual one. What do we want for this? Just got to find where the power's gone for this. No. I'm not actually showing it on camera because the other side of my desk is a giant mess here. Okay, question is, can I show you guys what I'm looking at? Oh, I think I can. I think this might just work. Okay, let's swap swap it out. Hold on a second. All right. This is now using the microscope on rather than my normal document camera. So this might work significantly better. Just get it out in front of me. All right, so let's zoom out a bit. So where's Q2? Can you guys see that, by the way? Is that popping up for everyone? It's showing here. Hopefully it's working for you. Okay, so there's Q2. That's the tiny little chip that we just placed now. Let me know if that's working for you. It seems to be showing in OBS okay, but it'd be good to know that it's working for you guys and that you can see that video as well. Okay, what will we move to next? The inevitable is going to have to start soon, and we're going to have to work on these capacitors and things, which is fine, but a little tedious. So let's move on to a few of these. What have we got? 50 NF. Okay. Have you guys done much of this sort of soldering work at home? Who's done a surface mount stuff? Okay, so we're going to be running C36. I might just zoom this out a little bit more if I can. Oh, that's as far out as we can go. C36, there we go. Right after getting things out of their tiny little casings, flipping them over is a real pain as well. C36. Not so bad with capacitors because they can generally go on either way, but resistors can be a good fun job flipping them over. C34. Okay. So in terms of where things are going with this Dropbear, I know it's a lot of people are waiting, and I know it's been a long wait. It's been a long wait for me too. But the intent is that I'm going to do a single run of one of these Alpha 4 boards. This will probably be the only one ever made. And then I'll test it out, and assuming it all tests okay, I'm going to move into a beta. Now, what that... Oh, God, I'm making this worse. What the beta will be is essentially some My goodness me. Some fully made boards. Probably a run of, I had been thinking about 20 or 30, but there's so much interest in them that I'll probably look at going maybe around 50, if there seems to be enough interest to do that many. They will be fully encased, fully, ready to go. No different from what the production ones are intended to be. So I'm really expecting that will be out before the end of the year, probably fairly close to the end of the year. Um, yeah, I'll have a few bridges here, I can tell that, but honestly, it doesn't really worry me that much. Fixing up bridges takes not very long. Um, and in some cases, or in some ways, it's easier than just starting again, in my opinion. It's not ideal, but it'll work. I'd never do a hand assembled board like this for someone that I was actually selling to, but for my own testing, if there's issues, I can fix them up. I've got a friend of mine or a colleague of mine down in Melbourne who's done a really, really impressive home DIY pick and place machine. Um, and I would love to get something like that here. I probably don't do enough volume to justify it, but boy, it'd be wonderful. Okay. Yeah, I certainly don't claim to be an expert in any of this. Certainly not in actual hands-on hardware layout, but I know just enough to be dangerous, I guess. Where are we? R28. Good enough. Yeah, doing DQFN stuff, that probably makes a lot more sense. Um, for doing this kind of level of stuff, you can see it. You can see solder bridges the moment you've done them for virtually all of these parts. Um, if they need fixing, then they need fixing. It doesn't bother me too much. Okay, a couple of the big tantalum capacitors here. Where are they? There, C4 and C5. Sharing my knowledge with the community. Yeah, look, if only there was a little bit more knowledge actually there to be shared. Um, look, my goal in all of this has just been to create an ECU that didn't cost the world, but that also wasn't garbage. Um, and I think we're slowly starting to get there with that. Maybe not quite there yet, but not too far off. I have to say though that that doing this on a stream does add somewhat more pressure to you than just sitting out here doing it by myself. Feels like having someone looking over your shoulder all the time, which is kind of amusing. Yeah, close enough. Oh man, where did I put my scissors? Too much chaos out here. Where did I put my scissors? That's a good question. Yeah, look, learning to solder is a bit of an art form, I suppose. It's like learning to draw or something like that. Um, Best advice I can really give, and it's just my personal experience, Michael. Um, Make sure you've got good solder, and make sure you've got a reasonably good soldering iron. It doesn't have to be the greatest thing in the world by any means, um, but it can make a big difference, particularly the tip on it. I remember a few years ago, I bought some solder, just a regular old reel of solder, um, that was lead free. Um, and I thought, I'll try this. And I stashed it in the drawer and forgot about it. And went to use it a couple of years later. And I hadn't done a lot of hand soldering at that particular time. I'm pulling it out and I'm soldering and I'm making a mess of every single solder joint that I'm making or that I'm doing. I'm thinking, geez, have I actually forgotten how to solder here or something like that? Um, but it just turned out that not only was it garbage solder, but it was lead free, and lead free is an absolute pain to solder with. Um, so make sure you're not using something like lead free solder because it will make your life terrible. What are we looking at? R23. Here. Popping something under one corner of the board here because it's just a little bit off. There we go. All right. 23. Unfortunately, the microscope does get in the way of working a little bit. There's a couple of little arms on it. Let me just move them up a bit. Doesn't provide an awful lot of clearance is all. 29. Oh, try again on him. Okay, R55 over here. Ooh, that chip's moved a little, hasn't it? Just a bit. Close enough for now. Oh, I cannot hold on to this particular resistor. So other than what's been announced in it, is there anything that you guys reckon is missing from the Dropbear that you'd like to see? The usual ones I get are typically, why not build a wideband on board and why not build the knock on board? Both of which are ones that I won't be looking at. They're probably things that I think, by personal philosophy a little bit, but that I think are better left off board. And I think also complement the target market a little bit better. Onboard widebands are a good one. They're one that frustrate me a little bit because one, they're so cheap. Why wouldn't you just get an external one that you can have a gauge with and those sorts of things? But also because they take quite a lot of wires to bring back to the board. Now, I'm not saying that putting them on board is wrong by any means, but I think there are a lot of advantages to keeping them off board. Yeah, I did. So I used a stencil on this one, Joseph. It's a pretty rough and ready job, but we'll make it work. A number of times I've gone to search for a component and just swapped the component number around and realized that I'm searching for a capacitor with an R reference rather than a C reference. It scares me. So I looked up R14 then instead of C14. I do that all the time. I'm going to keep checking myself. Although in some cases they're right beside each other like that, which is handy. So one of the cool things that I'll show you a little bit later, if you're all hanging around for the stream, um, will be the new map card setup that I've got on here. So on the Alpha 3 boards, we had two map sensors, or sorry, we had a map sensor and a baro sensor that pointed up off the board. And that was a nice simple design, and it meant I could keep using the same sensors that I'd used previously on a couple of different designs, but it turned out to be really problematic in that you needed to have quite a sharp turn on the hose coming off that in order to make it onto the connector, the bulkhead connector in the case, which wasn't ideal. Oop, it's not ideal either. So what I've done in this new one is come up with a design that lets me have pluggable cards for these sensors. So in essence, just have a tiny little card. Let me show you one of them. Not sure how much you can see of that because it's quite zoomed in. But that is quite a tiny little card. Hold up the camera. There you go, tiny little thing, which will have the map sensor on it and simply plugs into the board. Not only does it mean you can easily swap out a 250 kPa sensor for say a 400 or a 500 kPa sensor, but it means that the sensor all of a sudden is at right angles to the board. So we just have a nice tiny little hose connecting from the board straight up, or from the plug-in card up to the map sensor, up to the bulkhead fitting on the case, which should make it really easy and should make it really nice and firm and secure. And so I'm really happy with how that's come out. It seems to plug in and work really well. Now I haven't actually put one together to try it electrically, or electronically I should say, but it was mostly a mechanical change and it was mostly mechanical doubts I had about it, but they seem to be working really well. It fits physically really, really nicely. And the way it is designed to work in the board is that once you plug that card in and you put the top of the case on, it closes and pushes that board, or holds that board in into the socket that it sits in, so it can't come loose at all. There's about 0.5 millimeters tolerance there to hold the board in place, so it works really nicely. Which one's this? That's interesting. That's not a part I have on my board list, my BOM. Just comparing part numbers here, 12977-1. Look at that. That's DigiKey just keeping us on our toes there. I don't know what that component is, but it is not on the bill of materials. And given that the bill of materials was copy and pasted onto DigiKey's product importer, I can only think that DigiKey have given us an extra capacitor there for some reason. Onwards and upwards. I still have no idea where I put my scissors out here. Disappearing scissors. My shed is still an absolute pigsty. I actually sat down and cleaned it up. Well, cleaned up the bench area at the very least yesterday. But man, is it still filthy out here. Okay, these are our
Any ideas?
ton of these little caps. We've got 14 of these fellas to put in. Come on. Okay. Where are we? Up here. EBCS. Michael, I'm gonna claim ignorance here. What's EBCS? I don't know it by that acronym, whatever it happens to be. EBCS, electronic boost control solenoid. I don't know. Let me know, Michael. I'm not sure what that one is short for. If you wonder why I'm looking at the screen all the time, the when I plug the HDMI out on the microscope, it turns the screen off, so I can't see what the scope is showing in well, microscope, unless I look over at the laptop. Oops, not bad. 11. Well, I've got all this finished, and we wrap up the stream for today. One of my one of my jobs for the weekend and for Sunday here is starting something that I've never really played with before, but my wife has requested we do some proper Christmas lights this year. So I'm going to be going and figuring out how to use the fancy new, really fancy actually, Christmas light controller board that I've gotten, which I have to say I never knew there was quite so much involved with Christmas light control. But it's an interesting challenge electrically in a lot of ways. It's something a bit different from Speeduino. C12. Yeah, okay, it was electronic boost control solenoid. Yeah, so these are the ones where the boost control, rather than being an actuator where you're modulating the reference signal, um, simply have everything built into them, and it simply controls the wastegate directly. I would really like to get that in, and I don't think it's that difficult. Um, I honestly never understood why we ended up with the actuator system that we did, um, rather than something that works directly with a stepper motor or something like that. Um, but yeah, I think that's definitely something that we should support. I need to get my hands on one to have a bit of a play with it, but they're fairly common. What are they in a stock? I think BMW started using them, didn't they? On a stock setup. Could be my memory failing there, but C20. And the one above it. Well, that didn't work. Not bad. That'll be good enough. Alright, we're getting there slowly, guys. Well, that said, I pull out another big pack of things. 19 1K resistors. There you go. Common upgrade on Subarus. Okay, interesting. Pulling them off what, Michael? As in, are they aftermarket controllers that people are putting on, or are they pulling them off something else and putting them on Subarus? Yeah, don't sneeze, James. You're not kidding. Um, the number of times these come in little strips like this, little resistors. Where are we? There. Um, and getting them out of their little plastic thing can be both difficult and fraught with danger. And the number of times I've been peeling the little plastic strip back that holds them all in, um, and you you move ever so slightly, and the little plastic strip just flicks, and they can go everywhere, and you get no hope of finding them. Thankfully, for something like this, a 1K resistor, I'll have a bunch of them, spare ones somewhere. But for some of the more exotic components, you can be well and truly out of luck. Carefully peeling the thing back. In fact, we'll do half and we'll pull the other half back in a minute. Okay. Yeah, that's going to be a mess. There might be a few solder bridges there, but we'll sort them out. Yeah, it's a long process. It really is. It takes a long time. Um, Thankfully, it's only something I generally do, um, just once off for testing. These ones we can just do a line of these. I'm just amazed there's still 32 people watching me tediously putting resistors on a board. Good stamina, guys. Lewis is an interesting guy. He does some interesting streams. He's got a great setup too. Oh, yeah, we're going to start on this big line of, look at that big line of resistors. Ooh, look at that. Oh, look at my fat fingers here. Not so bad. Yeah, I did debate whether to get some of these made instead of doing this one by hand, but I really only need the one test board. Alpha 3 was 95% of what I wanted anyway. Um, it was nearly there. Um, Now, a few things were intentionally left off the Alpha 3 board to save cost and time, namely the VR conditioner circuit and a few other little bits and pieces. Did I just drop that resistor? I think I did. Um, and the intent was always to have those on board. Um, that's been added onto this board, and I'll do that one at some point. Um, but yeah, so really this is a verification. Wow, just shot that resistor into space. Um, this is mainly just a verification board to say, okay, yes, is that circuit working? I mean, it should be. It's been the same circuit's been used in a bunch of different things. A squillion of the little VR conditioner boards. Um, but yeah, really, this is just verifying that. And it's adding the cute little things like the accelerometer um, that we can have a play around with and see whether that works before doing a mass run. I knew this was only going to be for myself, this one, so I put a few things on to play with. It does take a little bit of patience, but you're under somewhat pressure as well because once you lay that solder paste, you can only leave it down for so long before it has to be used. Um, so nothing like a little bit of pressure to keep you motivated. And hell, nothing like 35 viewers on a stream keeping you motivated as well. That's all the 1K resistors. See, I said that, and the next packet I grabbed was more 1K resistors. Not quite sure what's going on there. And they're not on the bomb either, so where are these coming from? Don't know. Either way, we'll put them back. Okay. The most requested feature, oh, knock sensing, by far. Everybody wants it. Now, I think there's a lot of, um, how do we say, misguided views on why people need knock sensing. Um, it has its place, but it doesn't, it's not magic. It doesn't amazingly make your tune 10 times better and auto tune your ignition table or anything like that. But by far, knock sensing is the biggest one. And that's where Speedy Knock is going to come out at some point. At some point. Um, I actually have um, I actually have some really cool stuff happening with Speedy Knock at the moment. Um, I talked a little bit in the stream when I was working on it a while back about why it had been delayed and why it had taken so long. Um, and part of it was just because it sat on the shelf for a bit while I wasn't working on it, was focusing on Speeduino stuff instead. Um, 6 or 8 sequential, 6 or 8 sequential, kind of. Um, I'll finish on the knock topic and I'll come back to that point about the 6 and 8 cylinder stuff. Um, with with Speedy Knock though, it was part of it. Why it sat was because what I really wanted to do in terms of getting a proper knock gauge up that could talk to the ECU was proving really difficult, and I wasn't sure whether I would keep going down that path or whether I would look to just do a more DIY type setup where people could come up with their own 3D printed case or something like that. The What I had been planning to do, where are they, was use a little proper 52mm gauge like that, um, and build it into that. And that was proving really frustrating, trying to get that off the ground. Um, but the good news is I've actually had a little bit of progress there in the last 2 weeks or so. Um, and tentatively, fingers crossed, um, I'm really looking forward to hopefully being able to actually keep up with that and make that happen. So there might still be a developer friendly test board that people can 3D print their own cases for and muck about with, just as a way of doing it cheaply and doing it fast. But the hope remains to build it into one of those snazzy little cases. And I think that might actually be possible. Hey, Denver, lovely part of the world. I went to Denver a long, long time ago when I was a kid and spent a bit of time there. I'd really love to make it back to the US at some point. If it wasn't for COVID, I think I'd be starting to plan a trip over there just to catch up with a few folk. Um, but tentatively, I'm hoping to make it out next year once all this COVID stuff wears off. Um, there's a project that's in very early days that I'll share more on a little bit later. Um, but I'd look to come out to the US for Speed Week when that happens. I think that's October next year, about a year's time. It'd be great to actually meet a few of you guys because a lot of the Speeduino community is in the US, unsurprisingly. 36. Um, Watch this space, James. Great to hear, SB Tunes. So no matter how long this project goes on, and how many boards are out there, and I don't know. People ask how many Speeduino systems are running, and I honestly have no idea. It must be close to 2,000 at this point. Um, even that's assuming that maybe 2 in 3 boards actually get used and don't sit on the shelf or something. Even assuming that, there must be close to 2,000 running now. 59. Yeah, no matter how many of them are out there, I still love hearing that people are getting enjoyment out of it and that it's working for them. And uh, that's exactly why I did the whole thing in the first place, just because it's a cool thing to hear. Oh man, this resistor does not want to flip over. There we go. So release date on the Dropbear. So actual final release is not going to be until next year. Um, the beta should happen this year, um, which will get, like I said, I don't know, maybe 50 of these out there, into people's hands. Are they good enough? They're close, aren't they? Um, but yeah, the actual release of this, maybe Feb or March next year. Everything at the moment, and it's really frustrating. Everything is slowed down by shipping times, and I know, we're all going through it with COVID at the moment, but every single time I do a board run and every single time I work with a manufacturer on something, it's just add seemingly 3 weeks to the process for anything at the moment, and it's really frustrating. So it makes everything that little bit slower. Um, you know, I'm pretty slow to begin with in terms of getting this stuff actually ready. But it doesn't help when every last little thing you do is getting delayed by that much. When I say 3 weeks, that's not 3 weeks just to get the post to me. It might be an added week to do that, but it's an added week for the PCB house to get their parts from the supplier, and everything is just slow and delayed, unfortunately. Thoughts on a speedy knock daughter board? Yeah, look, it's a thought. Um, also, there's a lot of comments here. It's a thought, but I don't know. I kind of think, why bother having a module that you put on board, when you can just have a separate unit. Um, don't want that one. These ones. Uh, Open public beta. It will be an open public beta. Yep, but it will almost certainly be first in best dressed. Um, so I get a lot of people pinging me saying, "Hey, put me on the beta, put me on the beta," and until I know exactly when it's going to happen, I don't want to do that. Um, I will announce it everywhere once it's ready to go, but it will be first in best dressed. How's the fitment? On the two connectors at the front, pretty much perfect. Um, Pretty much perfect on the connectors. Pretty much perfect on the screw holes now as well. Um, this is the fourth alpha board. It's taken. Yeah, the first one was garbage. The second one was usable. The third one was good. The fourth one just tweaked things ever so slightly, but is pretty good now. That is fun getting that right though, because these cases are, people mock them because they're an AliExpress case, and they are. I'm not going to hide from that. Um, but there's nothing wrong with them in terms. Jesus, I just lost the capacitor. Um, there's nothing wrong with them in terms of quality. If you've had your hands on one of them um, and actually played with them, they're fine. Well, I did just lose that capacitor. I thought I'd gotten all of them out of this packet, and there was one left. I'm gonna have to find him. But the quality is fine. What you lose out on though is the fact that they just do not have good technical drawings or anything of them. So you ask for some drawings and you'll get back something that looks like a technical drawing and you go, oh, this is fine. And you actually go to use it though, and you realize that half the really, really critical dimensions are just not there. Um, Interesting. This is another set of chips or components that aren't actually needed. That's interesting. I'm wondering if I've mixed another set of parts in here by accident. Let's pop these back in. Because these are absolutely not on this board. I thought I had things nice and neatly organised, but for some reason I've got way too many components here. Don't have to worry so much about that capacitor that I dropped. Onwards and upwards. I'll actually check these this time. Yep. Yeah, DC Works. Dwight makes a lot of really cool videos. He does. He was one of the earliest guys to get on with Speeduino. He's been around in the scene for a long time now. He's a great guy too. Really great guy. He's another guy I'd really love to meet. He lives over in St. Lucia from memory. No idea when I'd be able to make it over there. But he'd be a great guy to meet. 15. I think I'm going to do all my boards on streams going forward because this is the only board I've ever assembled that I haven't had my kids running in and asking me to play. Oh, I just flipped that resistor somewhere too. Asking me to come and help with this or help with that, and I'd love to do that, but these boards you've really got to do in one go. My goodness, where did I just launch that to? That's not good. Bummer. Wonder what it is. R15. How critical is that resistor? We can leave him off. That's just part of the flex circuit. We can deal without the flex circuit for the moment. Bummer though. Wow. Well, I've got to get one, I suppose, but R11. Estimated time to finish soldering a board like this. Yeah, good question. They probably take, wow, I would have said 2 hours, but I'm coming up on 2 hours running now, and I've still got quite a bit of work to do. So I'd say probably 2.5 to 3 hours it's going to take me. Stop over on the way back from Drag Week. That does sound like a good idea. St. Lucia wouldn't exactly be the worst place in the world to spend some time. R11. These boards do always take a lot longer than you think they will. That's for sure. Am I using the SPI interface? Yes, I am. There's not enough I/O on the Teensy to do 8 channels of fuel and ignition if I was using the parallel interface. So yes, I am using the SPI interface for that and quite a few other things actually. It is an interesting little chip, isn't it, that MC33810? They do a lot of cool stuff, some of which I'm not actually using in terms of the ignition feedback and things like that. The one really frustrating thing with those chips is that the ignition current on them is really low, and they are intended purely just as a simple gate driver, which is fine, except that their drive current is just too low, which is really frustrating. You get some smart coils, and they are smart coils, that have an igniter built in. VW ones are notorious for it, but that they still need 20 milliamp drive or something like that. And I think the output on that board was only 1 milliamp or 2 milliamp or something like that, something really tiny. And I don't know, they're obviously just built specifically for a purpose. And yeah, it's frustrating. Now, how I've gotten around that is by connecting those outputs to the outputs, the gate on a TC4424, 4427, I can't remember off the top of my head, and doing it that way. So we get the full, those things can drive a couple of hundred milliamps. So you get plenty of current that way. But it's frustrating that there is that need to add the extra chips on. If they're meant to be a standalone driver, they should really be standalone. Oops. You can see that here we've got, so this is where those 33810s go, the big fellas, and these U8 ones here are the separate ignition drivers that I'm using with them. Where are we going? There. Oh, has the mic gone weird, has it? Can you still hear me okay? Was it something permanent that happened when the mic went? Or is it still just okay? Oh, choppy. That's no good. It's showing up on the system okay. I wonder if it's something on the stream that's gone a bit funny. My kids have probably started downloading too many movies or something. We'll give it a second and see if it comes back. It's yeah, it looks all right on the systems. I can only imagine it's a streaming type thing that might be an issue there. R21, not R31. Can't type. Oops. Sorry, couldn't see that one. Seems fixed now, does it? The audio any better? So for those just joining, this is the assembly of a Speeduino Dropbear testing board. Oh, and we are slowly but surely getting there. The pile of bits is shrinking quickly. Touching the PC fixed it. The magic hands. Could do a Fonz and knock the PC and just send it launching off the bench. Up to 100k resistors. 34. It's always good to see these big lines of resistors starting to disappear or starting to be filled up. Do you like the Dropbear logo, by the way? I reckon it's so cool. I'm completely biased on that, I realise that, but I still think it's a cool logo. The old debate about VR versus Hall. It'll be waging forever, I think, that one. Three, 42. Okay, we must nearly be getting there. Just looking around, there's not a lot of resistors left. A few capacitors here and there, but not a lot of resistors. I'll have to dig through the box in a minute and see what's left. We might move on to, I've sort of emptied the stack of stuff that I pulled out an hour or so ago. I might move on and we'll do a couple of the big ICs next, I think. Some of the more sexy stuff. Ks, 25, okay. You do bump components as you work around, by the way. If you look, there's a couple of little components that are a bit skewed. I just launched another resistor onto the floor. Let me see if I can spot him. What a mess. Been pretty sloppy today. I don't usually launch this many resistors. Alright, that's okay. We can probably deal with it still. These are all part of the analog circuit inputs. So as long as I leave one off from the spare circuits, I'll probably be right. I will have some spares around somewhere too. So I can leave off R56 or R58. Probably the ones I've already placed, are they? No, they're not. Okay, so I can leave those two off. That's all right. As long as I do 26 and 47. Because this is a test board and I've already tested all those spare analog inputs, it doesn't matter too much if one of them doesn't work. I'll just need to keep it in mind and not wonder why that circuit didn't work when I go to test it. When you pick a part up with tweezers, the chances of sometimes it just absolutely disappearing are crazy. And I actually saw that one go, and it went down, and there's more, offcuts and solder crap that's fallen onto my floor than I can poke a stick at. So it's sort of chances of finding it down there are remote. All right, what are we going to do? What's something a bit more interesting that we can lay down? Oh, we can do the VR sensor. That's always good. And we can do some of the big sexy buggers. I need to be super careful because I don't want to lose one of these guys. Not even a little bit. Okay, we're going to do this fella, which is the system controller. Now there will probably be some solder bridges for this guy, but that's all right. We'll fix them up. I don't think I've done a single one of this particular IC yet without having a solder bridge on it, but we can always fix them up. Okay. I'll double check that I've got this around the right way. I do. It's fine. That's pretty close. Yeah, that's pretty close. I'll double check it again before I put the heat on it, simply because they can move just a little bit. Now, oh no, if there's any components that I do lose that go flying off into space and I really do need, I've got so many other test boards here that I can pilfer them from. It's not funny. Line these suckers up. Not bad. Yeah, not bad. So in case you're wondering, that pad in the middle, it's basically a big heat dissipation pad. And you can see if you look at the bottom of the chip that they've actually got, I can't really turn it around I'm afraid, but they have a pad on the bottom to dissipate heat out of. Ooh, too much. That's not bad. No, it's not great, actually. There we go, that's pretty good. Good enough for now. Right, that's a couple of the big sexy chips. The other one, we'll do this VR chip. Now, because this wasn't on the board previously, I'm just going to need to look up the orientation for this one. Okay. It's got a big circle marking. That makes it nice and easy. So pin 1 there is over there. Okay. I remember the first time that this was when I did one of these years and years ago. It was the first really, really fine pitch IC I ever did. I think these are 0.4mm pitch, by the way. I was so proud of myself when I got a board that worked with it. These days I'd just be so annoyed with myself if I didn't. That's not great. It's better. Yeah, we'll put some heat on it and see how we go. Alright, what else have we got here? What have we got left? We've got some of the bigger caps. We've got the ignition drivers. Let's put the ignition drivers on. Where are they hiding? I've got some fuses. Let's lay a fuse down. So this fuse, yeah, this is another 0608, 0603, sorry, fuse. What's that, 94? Okay. So there are some smaller discrete components, but now I'm not necessarily sure that I'm happy with this particular circuit design. This is a fuse on the output of the voltage reference that goes off board. So obviously anything that goes off board needs to be protected. But I'm not necessarily sure I'm happy with this particular circuit yet. So this is one that may change after I test it. Where are we? It's not bad. Keep going. The second fuse is just one that goes on the power line for the ignition output. So just in case somebody shorts one of the ignition lines. Here's an interesting one. Let's do this. This is something else that's new. So I'm going to have to look up its orientation as well. I've switched to the different barometric pressure sensor for these. This is a nice little integrated one, which is look, in a lot of ways it's just a much nicer chip, but I've not used it before. So let's have a look at him. I haven't even seen him. Okay, so he's got one. I'll drop it beside the pad. There you go, you can see in there. You can see it's got one big fat leg there. Maybe you can't. Oh, there you go. Now I'm assuming that's going to be pin 1. Let me just have a quick look just to make sure. I'll look up which one is pin 1 anyway. It's that one, okay. The more I looked at these, the nicer they are as a chip compared to the ones I was using previously. Let's grab the data sheet. Whoa, it's a big data sheet. Must be in here somewhere. Ah, interesting. Okay. So the big fat pin is actually pin 8, not pin 1. That would have been a nice trap to fall into. Pin 8. Alright, so pin 8. Which means we've even got it roughly on the right orientation. That's interesting. That's slightly bigger than that footprint, isn't it? I wonder if I got the wrong footprint for that. What have I got? Oh, that was a keycode component off that I got pre-made. So that's interesting. Yeah, that is the wrong footprint. When will I get a test batch of the card-based map sensors? Well, I'll hand assemble a couple of them and then get them made. Look at how far do they go under? They don't go very far at all. Will that work? Boy, it might just work. Look at him. Yeah, okay. So this is why we do test boards, fellas. That might just work, but it's going to need some hand playing with, I think. Ooh, okay, very tight. So that is in essence the wrong footprint. Whoever's made that part has put the wrong footprint on that. I'm going to leave him off for now because I'm going to have to do that one with a little bit of finesse. That's okay. We'll sort him out. But yeah, that's a good reason why we do test boards. Put him back in his bag. So that is alright, we can live without a barrow sensor for the moment, but obviously need to get it fixed. Now, what's next? What's this guy? CAN transceiver, of course. So CAN is certainly something a lot of people have been interested in. Just if for no other reason than being able to hook this thing up to existing dashes and things like that. The code support isn't there for it yet, but it will be coming. Which way does this sucker go? That way. Yeah, some of those caps have really moved around, you can see. Good enough. Those caps will be good enough too. Another new part, there's a logic gate that works with this accelerometer. Just look up his orientation. Can't even get him out of the packet yet. Yeah, exactly right. Reasons not to go straight to a customer test. Not for anything new. I learned a long time ago that you think you're doing the smallest little change in the world. Yeah. We're only changing two tiny little bits, but whatever it happens to be. But boy, it would be the number of times tiny little things can go wrong like that. It's unbelievable. Um, this one doesn't surprise me too much. I hadn't worked with that sensor at all. It was a brand new one, and I guess I just placed a little too much trust in whoever did that model in KiCad. It's a good lesson. Always check your footprints. Yep, cool. You can see there's a bit of a mess of solder here, but that'll all clean up. Doesn't worry me at all. Whoop. That's not bad. It'll probably be right. So that's just part of a little logic circuit that works with the accelerometer. Because it's all sharing a common SPI bus. The data sheet for the accelerometer called for that little logic circuit to go in as well. Yeah, this is our big power transformer. ZT set. And just little things that you pick up, such as the fact that this is Q1 that I'm going to be putting on next. Where are we? Up here. And I only just caught the fact that I was looking. I happen to know where this part went because it's a pretty obvious one. But the Q1, the silk screening that indicates where Q1 is actually here. You can just see the top of it down there. I obviously haven't relocated that silk screen to the right place, so it's hidden under the pad of that capacitor that's below it. So just little stuff like that that can be fixed up for the next revision. And again, this is a new part. This is swapping out the power circuit that was used previously for an updated version that I'm now using in the Miata plug and plays and those sorts of things. It's a bit of a beefier circuit. See, it's got a nice big cooling pad there, and if you look at the back, there's actually a nice exposed thermal cooling area as well. Alright, let's start getting a few of these big caps on. That's all right. So to try and squeeze up a bit of space here, I've actually dropped this cap into, it sits inside the stepper motor driver area now, just to free up a bit more room. You can see that there's a board cut out here, which is where the USB connector goes, the waterproof USB connector. So that drops in there, and that needed to go as low as possible. So it needed a lot of fiddling around to try and make things work physically. These ones you can just about pop in by hand. They're so big and chunky. Gotta make sure you get them the right way. You can see that for these caps I'm using what's known as a caged version. It's a little bit blurry. Okay. You can see sort of that they've got a little cage around the cap to hold them more steadily in place. Now, realistically, on the final version of these, I'm probably going to end up just putting some potting around them to hold them in place. But the caged option is still a good way to go. Alright, a whole bunch of little diodes now, which is always fun because you've got to watch for polarity on them. So what have we got left? We've got a couple of capacitors, we've got all of these diodes, we've got the LEDs, and we're just about done. The LEDs I hate doing. They are a massive pain because of the polarity marker for them is on the bottom. So it's so easy to lose track of which way around the polarity is when you're placing them. Cool. Over here. And these are tiny little diodes, and I'm not a massive fan of them actually. I might move to a different diode in the final version. little bit short on solder paste on that one, but I think we'll be right. Ones are really tricky to see the polarity on too. These ones are also ridiculously easy to blow away with the heat gun when we're doing the soldering. That one I'm not sure. That one we might have missed the solder on actually. Yeah, he looks really dry. Just lay a touch more solder down there. Just going to do it for all of these because they all look a bit dry up actually. Just made a bit of a blob of solder, but it'll come clean. Believe it or not, system, these are actually really fine-tooth tweezers. These are electronics tweezers, but they're obviously under the microscope they still come out pretty big. They're certainly the finest ones I've got. Like I say, I just made a bit of a blobby mess of solder there, but it's alright. Spin this guy around. Having just worked with them again, I'm pretty sure I'm going to get rid of those crappy little diodes. I hate working with them. What do we got? Oh, starting to get there. Flip it over. Get off. I do wonder why I bother with some of these components sometimes on a test board, because these are already tested circuits and it doesn't matter too much if you lose some of the protection on them. These are basically the flyback diodes on the outputs. So if you're running an idle valve off one of these, for example, these just absorb the inductive kickback on them. Would the circuit work without it? Yeah, it would. And if you're running like a fuel pump or something off it, then it doesn't matter at all. Oh, okay. What do we got next? Really finer tip ones. Okay, I'll have a look into those. I mean, these are they're pretty pointy. For comparison, there's a micro USB just for size, so it's about the same as that logo. So it's pretty small scale on most of this stuff. What do we have left? Another big capacitor. TBS diode. Now you'll probably notice that there's a few through-hole components still on here as well. I'll do those last after we've done the heat on the surface mount stuff. things I've always been really curious about is how DigiKey do their packaging up. I'd love to see it because you place an order on DigiKey and it can have, quantity 1 capacitor, tiny little capacitor like this. And they send you out, sure enough, 1 capacitor. But they've got the whole thing packaged up and out the door 2 hours after you make the order. So there must be some seriously impressive automation going on there. Another big cap. Honestly, this one I could probably swap out for a smaller capacitor. Just going to put him in by hand. This one will be a caged capacitor as well once it goes to the final version. Okay, got little slide switches. I hate these little suckers if for no other reason than that I've not yet figured out a good way to pop them on and solder them on with a gun without melting them a little bit. They still work, but it looks less than ideal. When you get them manufactured, it's obviously not a problem, but for hand work, it's a bit of a pain. Now they do thankfully have a couple of little holes that you can see which help line them up. You pop them in the holes and they basically just fall into the spots. Yeah, one of them is laid out ever so slightly higher than the other two. I've got to fix that. It's just me being sloppy. So those three are for switching between Hall and VR for the crank and cam, the map source, whether it's internal or external, and this one's for the ignition power, whether you want 12 volt or 5 volt. Oh, come on, fall in. Now I've got the TC4424s here, but interestingly there's only 2 in the packet. So I'm wondering if I got the bomb order wrong, which would be a little bit sloppy of me. Yeah, heated plates is the way to go. You're absolutely right. Yeah. So it's not actually a problem that I've only got 2 of these. I will have to check the bomb that something hasn't gone on weirdly there. But given I'm only going to be testing on a 4-cylinder car, this doesn't really matter. Enough. Right, what have we got left? We've got all the LEDs to do. Always a pain. What else? Can avoid it no longer. Let's do the LEDs. VVT PWM output, there sure is. Yep, that's absolutely there. Cool. Okay. I always have to look these up to double check the polarity marker because I can never seem to remember it. Show you what these look like if you haven't seen them before. I won't do it now, but I have posted up a link to all of the outputs that this thing has got, the inputs and outputs. I've got a listing of them around here somewhere because I've got the pin out here. But they're pretty extensive, and there's a whole heap of spare outputs and things like that, and spare inputs, and pretty much anything that the Speeduino supports in firmware today, this board has on board. Show what one of these LEDs looks like. Where are we? There we are. Ugh, dropped it. So that's the top of it here. But you'll see that the polarity marking is, let me get another one, on the bottom, which is always a bit of a pain because once you spin them over, you can no longer see what the polarity is, which always frustrates me no end. But let's, bear with me just a second here. What currents can the output handle? The The all of the like auxiliary ones, so the idle and VVT, I think from memory, they're 3.5 amps. Hey, I'm just looking at the data sheet for these, and I'm realizing that I think, if I'm reading it right, it actually says that there is a marker on the top, which I never realized. You can see one corner of these ones that are flipped over. This corner up here has a little white mark on it, which looks to be, if I'm reading the datasheet correctly, the anode marker. So that's one thing I hadn't actually realized before. Let me just triple check that. Because I'd hate to put these all on backwards. I have put LEDs on backwards on these boards before. It is crazy. Yeah, okay, well there you go. We can use that. Terrific. So if that's anode, which it looks to be, cool. So they should all go this way. Just look at one of the old boards. I'm going to verify that. One of the old boards. Let's just double check that we've got that right. Well, no, they seem to have the mark in the opposite corner. Well, that's interesting. That is a very old board, though. Curious. I think I've got it right, but that does make me wonder. That's alright, we'll put them on. If they're backwards, I'll flip them. Not the biggest deal in the world. Shouldn't have put these near the solder paste, should I? Sorry, I'll let you guys actually watch. Yeah, I will. I was going to say I wasn't going to bother chucking the other ones on, but I will because I'll test them anyway. These are from the injector outputs anyway, so. Well, that's good to know. That's something I hadn't picked up on before. If I can manage to get the little packet open, we'll put the rest on. Yeah, I'll go through the heat. Go through doing the heat on. Yep. I'll try and capture it as much as I can on the microscope here, without absolutely flaming my microscope. Obviously, normally you wouldn't bother doing it under a microscope, but for your viewing pleasure. Oh, I cannot get this packet of diodes open. This is crazy. Yeah, when a packet of components gets so difficult to open that you contemplate just leaving it off. Right, we're in business. Blacktouch. Okay, what are we missing? What are we missing? A couple of caps. Where are all the caps gone? Um, Ah, just knock the switch out. All right, and moving on. We don't have many components left here, so there can't be much left. Okay, these. Now looking at that, we didn't get much solder around Q3 up here. I'm going to do something that's going to disgust you all. Watch this. I'm just going to do this. I'm going to mash some solder onto there. That is filthy. Oh, look at that. Way too much. Terrible. Disgusting. Look at it. It's horrible. That's all right. We'll clean it all up. We'll fix it in post, as they say. I'm not worried too much. Just clean that up. It's horrible. It's disgusting. Avert your eyes. I've got to figure out which way this sucker goes. He's a tiny little wee one as well. That looks like pin 1. Let me just do a quick search. I just want to triple check that I've got this right. Yeah, we've been going 3 hours. Can you believe it? Yeah, that is absolutely not safe for work. It is filth, that amount of solder. Pin markings. Yeah, so pin 1 is the dot, which is cool, except that this has 2 dots on it, which is interesting. Curious. That's all right. Oh, I dropped him and he spun around. Would you believe it? I'd believe it. I'm making a mess of this. Definitely got nothing to do with how much solder I put down. Nothing at all. That's a special for you guys on the sloppy mechanics group. That's sloppy electronics right there. There we go, about right. Wow, that's disgusting. Absolute filth. What else do we got? C40 and C39 are missing there, which is interesting. Where are they? What are they? Just plain old .01 caps. Why are we missing them? Curious. That's because I put those two caps in the wrong spot. Go me. I realise what I've done here. What do we want to do here? Yep, I see what I've done. It's cool. Let's pinch these suckers and we'll move them over to where they should have been. Where did I find the music? It's only about an hour and a half worth of music, and it's on repeat. But the music is, by the way, just all off YouTube's music, free music archive. It's all pretty generic, but it's free and you don't get pinged for it. Ooh, how do I do this? Let me just turn the board. Sorry guys, I'm not sure if I'm showing you the right thing there. Cool. What are we missing? What are we missing? A few capacitors here and there. And that's it. Oh, and the baro sensor, but we'll sort him out. And that one, R15, what are you? 2.4K. Ah, there we are. This is the third time we've heard this song, by the way. These streams, like, it'd be so much better if we could just listen to the music that we like listening to. It's a bit of a pain when we have to just put on other stuff. 58. Oh yeah, that's okay. Alright, what else are we missing? C38. UF. No, that'd be you. Is that a wire over that chip? U10. Let me look. Where's U10? What's that one? No? Oh, I see what you're talking about. I think it's just some marks on the chip. Let's have a look. Enhance. Ooh, interesting. It's not. Well spotted. What is that? I think it's a hair. I think it's like a bit of fabric. Oh, I just put in some white plastic here. Can't even see it. There it is. Well spotted. Whew. I think it's just a bit of fabric. Yeah, it is. Sort of red fabric of something I'm wearing, maybe. Geez, you've got sharp eyes though, system. Whew. Zoom it back out a bit. No, no, it's a good point. If it was a wire, it'd be a pain. It can cause all sorts of grief. Yep. Okay, C35. We're nearly there, guys. I promise. 35. Okay. What is left? Let me take a look around because we are nearly there. Where are we? There. Is the music too loud? I can turn the music down if you want. Uh, 5C26. Where's C26? That's a good question. Hiding is where it is. The last little bits always tend to hide a bit. Alright, I think that might be it. Let's have a final little squiz. Oh, C30, no, C30 is missing, and C30 is an important one. Where's that? C28. Interesting. Dob another bit of solder on him. C30. Now C30 is an interesting one because I haven't seen that at all. Make sure it didn't get put over here. No. No, it's certainly on the DigiKey order. I don't know where C30 is hiding though. That's alright, I might have to come back to him. But that is the last one. That is everything. We have one final last little look. Now there's a couple of chips I've specifically left off. That's okay. I don't have a problem with that. There's U14 is a testing chip. It's got some extra memory on it. It's not needed for this and those sorts of things, so that's fine. Won't the earlier not safe for work solder cause problems? Maybe if it's bridged, I'll simply clean it up by hand afterwards. Dropbear kits? No, I probably won't sell a Dropbear kit. There's just not going to be interest for it. There really won't be. They'll only be sold as assembled boards. That's fine. All right, I think we're good to go, kids. Let's have some fun. Now, I warn you in advance, the hot air gun can be a bit noisy. Let's try not to melt anything that shouldn't be melted, eh? Where should we start? Let's start on Mr. Oh, we'll start with these ones. With, where are we? This set of stuff up here. And then we'll move on to Mr. Not Safe for Work. Make sure you guys can see it. This is really awkward doing this holding a board. Alright, who's ready for some fun? Yeah, so as expected, that's pretty messy, but we'll tidy it up. Whoa, just noticed that the heat knob had been knocked right up on this. It is too hot. Wondered why that was burning so hot. Phew. Oh, no, we're not putting enough. There we go. Try that. Doing this and trying to hold the board is a really good challenge. Some of those diodes are going to get messy. Yeah, that's all right. Okay, so we'll do some of these chips. Couple of solder bridges along there. That's all right. We'll fix them up. Yeah, I've managed to melt that switch just a little bit. I should put the iron on these by hand. That should actually do it better that way. It is a beautiful process, isn't it? Come on. A bit wonky on them, but that's all right. Those switches are tough. Trust me, I've melted every one of them. They still work. Oops. That looks neat. Ooh, no. The chip that's gone a bit wonky here. I'll just fix him up. Nope, he's already done on one side. Let's see what we can get. Yeah, okay, it pulled itself in a little bit. That's alright. What are we missing? Okay, and the lovely little fine pitch VR sensor, VR conditioner, sorry. See how we go with him. Pretty good, I think. Looks pretty good. I'm not going to do those other switches because I'll just melt the shit out of them. So I'll do them by hand. Come on. Now the fun little system chip. This is always a good challenge. Sorry guys, I'm not really able to pay attention to chat for the moment, so I will be back. Damn, I just knocked this capacitor out of the way. Sorry guys, just doing some quick adjustments here. I'm struggling to get heat into this side of the chip. Let's just move you for a minute. Okay, there we go. Yes, whoa, good solder bridge there. That's all right. Let's just have a look, see if I've missed anything. Oh yeah, because the resistor's over here. Anything else I've missed? No. Okay. Wow, that is really difficult to do. Trying to position things on camera and working at the same time. Oh, that's all right. That's empty. Phew, really difficult. Okay. Give me a second here. Shaky from the cover. No, my hands are shaky at the best of times. But no, it's really difficult to hold the gun, not burn yourself, not melt the um, the microscope, and hold things in the right place at the right time. In fact, there's a couple of spots missing on that chip, aren't there? What's that? U6. Yeah, okay. There's a couple that haven't quite melted there. All right, well, let's tidy these ones up first. This was a bit of a quick and dirty job, so there's going to be solder bridges. That's pretty normal. I'm going to turn the board just around this way a little bit. Where are we? Did I get all them? Yeah, they're right. that. Okay, what are we going to tackle? So, for those not familiar with them, what I'm going to be looking at here is here. You can see there's clearly some bridges between between a couple of the pads here. So we're just going to tidy those up. And yes, you can have a go at me all you like for that's because of my method, and it is. You're right, but it doesn't bother me too much. So what I'm going to do is lay down some solder wick here and just clean them up. I don't know if you guys can see that. The board moved a bit. No, try. It's so difficult to do this without bumping the board off this microscope. Let you guys actually try and see this. So those are all cleaning up nicely. Last pin didn't get enough heat. Let me have a look. Just tidy these ones up and I'll go back. Enjoy the laundry. I got moved for you. Sorry, guys. Yeah, hot glue would potentially work. I'm moving the board around quite a lot at the moment. Even blue tack actually works surprisingly well. But I'm moving things around quite a lot at the moment just to show you guys different things. So. They all look okay. Ah, yes, you're right. Rest look okay. Oh yeah, my technique is garbage. I don't deny it, but it's good enough for a test board. Well, actually, got a new roll of solder wick here. It's one thing doing this for yourself. It's another one doing it on a camera, trying to do it relatively quickly as well. Normally I'd do these more one pin by one or one bridge by one bridge, but let's see how we go. No, hold on. Yeah, those pins aren't great, are they? There's a bit of a misalignment there. I might look at wrapping up fairly soon, guys, for no other reason that I'm probably going to be called inside to help with the wife. But I'll keep tidying these up. There's a bit of work left to be done here, and it's going to be easier to do off camera. Yeah, hopefully that's been at least a little bit interesting for you all. Oh, this is terrible trying to hold the board under the camera at the same time. Ooh. Yeah, that's not great at all. All right, I might leave it there. Actually, I can put I can do these big capacitors by hand.
Any ideas?
Ooh, he's a bit burnt. That's all right. This is awfully difficult. Just got him. All right. I think I might just about call that quits there. Solder pad, solder pad. Sorry, Michael, I haven't been watching chat too closely for the last few minutes. Michael, where's your question? Oh, good question. Do I use large solder pads on the board design if I know I'm going to be doing hand place SMDs? I, I have on the first three alpha boards. On this one, I didn't. I switched the whole board over to non-hand solder boards simply to get ready for production. So there is smaller pads on this one, which adds to the challenge a little bit. What working distance does the scope offer? Good question. I can't remember off the top of my head, I must admit. Goes down quite a long way though. Let's focus on something. what's the spacing on them? Hold on. Oh, actually, I'll go for something I know of. Okay, so that spacing there that you're looking at is 0.4 millimeters between pins on those, if that's any indication. And that's, I don't know, 5 centimeters off the board, roughly. Yeah, from the lens to the light. At the moment, yeah, zoomed in all the way like that, maybe 6 centimeters between the lens and the board, Chris. So pretty tight. It was a little more when I zoomed out. So when I zoom out, if I get to there, I'll get a solder bridge there to work through. That's fine. That's maybe 10 centimeters there. Right. Well, that's a pretty rough and ready sort of job, but I'm just going to work through over a little bit. I'm going to go inside and get another drink and have a little bit of a break. But that's basically it. I'll tidy those up. I'll get the connectors on. Oh, I'll show you. Can you see it here? It's probably way zoomed in. Where are we? Oh, Matthew, so much. I really thank you so much. I really appreciate that. That's terrific. Where am I at in Oz? I'm going to Ballarat in Victoria. I'm zoomed in way too much. I'm now using the wrong camera. But there you can see one of the map boards plugged into the little socket that it goes in. Now, obviously, this will be ENIG finished and everything on the production versions. But they plug in really nicely. They're held in really firmly, and the top of the board, when you've got it mounted, got one around here somewhere, pushes down and sits right level against the top there, so that can't vibrate out or anything at all, which is pretty cool. All right, team. I think that's about it for today. It's been a super. Oh my goodness, we've been going for 4 hours. I can't believe that. Hopefully, it's been enjoyable for you. There's still 33 on you. That's incredible. Do I know a good tuner near Ballarat? No, they're all garbage. All the ones are, well, okay, that's not true. There's a couple of good guys around here that know how to tune but don't have dynos. So they use other dynos. There's a couple of places with dynos that don't know how to tune. There's a couple in Geelong or Melbourne though. Henry. All right, team. I hope you have a good weekend. What remains of it? If you're here in Australia, I hope you have a good Sunday. If you're elsewhere, it's probably Saturday night for you. So enjoy the rest of your weekend, and I'll talk to you all soon. Cheers, guys.